So we'll do a quick little review here of all the double angle formulas that we got in class.
And as a reminder, there's a one.
So all we did to get the double angle formulas was basically take what we've been doing with A's and B's, and you let them each be the same thing. So just call it theta and theta, or alpha and alpha. You do the formulas we've been working with the last couple days. The sine one comes right out to this. The cosine one comes right out to this. To get these last two for the cosine, what we did was we just did substitutions. So we went here and we said a sine squared is the same thing as a 1 minus a cosine squared, because we know sine squared and cosine squared is 1. That gives us this one down here. And then we went back to this one again. And in here, we plugged in a 1 minus a sine squared. And you get this guy right here. Okay? So those are 4 double angle things we had. Doing a very similar thing with the tangent, we get this guy. So we went to the formula we worked with today, and we just did tangent of a theta plus a theta. Okay, and this guy easily comes out to this guy right here. So those are our double angle formulas. Okay, the 2's in here with the theta, not out front. It's not 2 times tangent, it's tangent of some double angle. Okay, then we manipulated these guys a little bit further to get these power reducing ones. So we said cosine 2 theta is this. So we swapped these two guys, here and here. Then we divided by 2 to get this guy right here. Okay, we're going to come back to these a little bit later. So sine squared can also be written as this. We took this guy here, we swung the 1 to the other side, we divided by 2, and we get to this guy right here. So cosine squared can also be written as this in terms of a double angle. Okay. Do the same thing for tangent squared, so sine squared over cosine squared. Put both of these guys here because we're going to be multiplying by the reciprocal of this. Those guys will cancel, and you'll get here. We just rearrange this piece here so we get the ones on top of each other. Remember, you can't do this or cancel any of those cosines out. Okay, it's got to be factored products. So all formulas you guys have on your yellow sheet, we just have to be able to use them. Okay? Here's the kind of questions you're going to see. So sine of theta 5 over 13. It's going to tell you where theta is, and it just wants you to do some double angles. Okay? So took the triangle here, put it in quadrant 2. If we know the sine's 5 over 13, there's your opposite, there's your hypotenuse. Okay, and this guy should be a negative 12 down there. And all we have to do now is grab your yellow sheet and plug some stuff in. Okay, there's the big theta that we're going to use to get this here. We can call this guy alpha. Again, we don't care what it is. Okay, we're just trying to find sine 2 theta, cosine 2 theta. Okay, so you go to your yellow sheet, sine of 2 theta. We only have one choice. It's 2 sine of theta times cosine of theta, and all we have to do is go plug things in now. Okay? So off of this triangle, we copy the 2. We go here, sine of this guy. We already have it as 5/13. Cosine theta, we go back here, negative 12 over 13, and all we have to do is figure this out now. 2 times 5 is 10, times the 12, negative 120, 13 squared, okay, and that's your answer. So it's less than 1, okay, and that's what you're going to get. Cosine of 2 theta, you got 3 choices. Okay, no matter how you do this, you're going to get the same answer for me. Okay, so I'm just going to pick the first one on here. I'm going to do cosine squared minus a sine squared. Go to your triangle, plug your stuff in, and you'll have it. Okay, so cosine squared of this guy Negative 12 over 13, we're going to square that guy. Subtract off the sine squared. And I would encourage you to use parentheses and watch your negatives because those will change your final answers here. Make sure that guy is squared like the formula tells us. 25 over 169, okay? And get your calculator, get your final answer here. And you're done with that problem there. You guys' favorite now, we can also do identities with these double angles. Okay, so you see these two sides here. You're probably going to have to do something to the left side, and you're definitely going to have to do something with the right side. Remember, you can't do this. That's not allowed. Okay, just like you wouldn't do it with X's and Y's, you can't do it with these guys here. Right? So I'm not going to touch this left side right now. I'm going to go after the right side. What you guys got to think about is what you really have is an a cubed plus a b cubed here. Okay, so that is a sum of cubes, which you guys conveniently have on the back of your yellow sheet. Okay, that guy should factor into a plus b times an a squared, a minus b, plus a b squared. Okay. Now, we just got to do the same thing with sines and cosines here. So, we're going to say sine plus cosine times sine squared minus sine cosine plus cosine squared, okay, all over sine theta plus cosine theta. Remember, these other guys have thetas in them as well. We just don't always put them for convenience sake. Now, you can cancel this because it's no different than canceling something like this. 2 goes into the 4 2 times. Okay, it's a factored out property, so that guy can cancel. Okay, so that guy's gone. Now we just got this little piece left here on the inside. You get a sine squared. I'm going to reorder this. Cosine squared minus a sine cosine. We know this is our most basic identity. That guy's a 1. Now, there's definitely nothing more you can do from here. Okay, there's no Pythagorean identities, there's no more factoring, there's no more real substitutions. So you've turned that entire side into a 1 minus sine cosine. Somehow, you got to get this side to do the same thing. Okay? You see a double angle here, so go to your yellow sheet and see what you can plug in for it. Sines are nice because there's only one choice. Sine of 2 theta is 2 sine of theta, cosine theta. Those guys will cancel right out, half of 2. And you got each side equal.